They help you to understand, so it's good, but the reason I kind of hate them is because you don't get to use it on the test or the quiz. So I'm afraid if you get too attached to the little direction paper I'm going to give you, then you're going to be dependent upon it, and that will have a bad effect on your quiz. So I'm going to give you the papers next time. It just kind of reviews over everything we do today. I'm going to give them to you, but as soon as you can, I want you to just put those papers away. Okay? All right. Today we're going to start talking about rational functions. That's all that stuff we talked about, vertical asymptote, horizontal asymptote, all that stuff. Okay? So the graph y equals 1 over x. So we would never graph it like this, but I just want to make a table of values to kind of graph this one so you can get an idea. You guys, everyone look at this and tell me what x cannot be. Can anybody tell me? X can't be 0, right? You can't have a 0 on the bottom. So what you're going to do is you're going to dash a line right there at x equals 0. That restricts the value of 0. What is that called? It's called an asymptote. Yes, and someone even said it better. It's called a vertical asymptote. Good. Okay, let's put in a value. So let's say if x was 1. Then you put it in there, you get 1 over 1, which is a 1. If x was a 2, then you'd get 1 over 2, which is 1/2. If x is a 3, you would get 1 over 3. You guys, this is like the parent rational function, okay? We're never going to say take the rational function, move it right to, reflect it. We'll never do anything like that, but this technically is the parent rational function. Go to your graph and plot the ordered pair 1, 1. And then plot the ordered pair 2, 1/2. So if I go right 2, I go up 1/2. And then 3 1/3 is right 3 up 1/3. Somebody tell me what 4 would be? 1/4, and then 1/5. What would 100 be? 1 over 100, right? So is it ever going to touch the x-axis? Even if it's a million, it would be like 1 over a million, which is almost a 0, but it's not a 0. So it's going to curve down like that, okay? And then draw an arrow. What about 1/2? So if I did an x value of 1/2, can you tell me what 1 divided by 1/2 is? It is a 2, yes. So if I go right 1/2, I go up 2. Can anybody tell me what if I go right 1/3, what would I do? What if I let x be 1 over 3? Then y would be 3, and then 1/4 would be 4, blah, 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 and it looks like that, okay? That's half your graph. Now we're going to do the negative. So just make all these signs right here negative, and if I put in a -1, I'd get 1 over -1, which is a -1. So it would just switch all these signs. So I would go left 1 down 1, left 2 down 1/2, left 3 down 1/3, left 4 down 1/4, and it would curve over like that. You guys, I have another what in my picture that I haven't drawn yet. Can you tell me? Another asymptote. Yeah, and the asymptote is right there at x equals 0. Okay, and then keep going, left 1/2 and down 2, etc., curves in like that. Okay, so you have two asymptotes. One of them are x equals 0, and the other one is y equals 0. Okay, the domain, everybody look at the blue graph. Can you tell me the domain just very quickly? What is it? X can't be 0. Sure, they didn't tell me how to write it, so that's fully acceptable. Look at the y axis, which is the range. What's the range, everybody? Y cannot be equal to 0. Good. Okay, question 1. Find the domain. You guys, everybody in the room, I want you to answer this question. You better know the answer. When you're looking for domain, how many things do you look for? Tell me that. 2. Good. One of them is a fraction with an x on the bottom. Do I have a fraction with an x on the bottom? Yes. So you write down the bottom, and do you say that it must be greater than or equal to 0? Is that what you say? What do you say? Cannot be 0. What's the second thing you look for when you're looking for domain? Even root. Do I have that? No. So this tells you x cannot be equal to a -3. That's your domain. You're done with the problem. I want someone to stop for just a sec on that, though. You would literally be done. I want to talk about this. X cannot be a negative 3. So the value of negative 3 on an X can be restricted in 2 ways. So X equals negative 3 is either going to be this or it's going to be that. Can anybody tell me what the this and the that are? Say it again. You're right. You just said it, dude. A whole or an asymptote. You are exactly right. Now, I don't want you to worry about which one it is because we're going to get there in a minute. I just want you to know that X can never be a negative 3, and the way we're going to restrict it is one of those 2 ways. Okay? Okay, question B. I do not have an even root, but I do have an X on the bottom. So everybody go X to the second plus 3X minus 4. Look what some people are doing. Equals 0. Is that correct? No. So you got to be careful, okay? So some people are even do this. Guys, listen for 2 seconds. Some people are saying like equals 0, and then they get their answer, and then they suddenly turn it into like a greater than, when it was supposed to be a greater than to begin with. I'm talking about like an even root. So if it's supposed to be greater than, then write it at greater than from the beginning. If it's supposed to be a can't equal to, write it can't equal to at the beginning. Tell me with one word what to do here. Factor. Good. So it's going to go to an X and an X. Write down that can't be 0. The 4 goes to a 4 and a 1. Signs are different. Biggest is a positive. Looks like that. So you have a restriction that X cannot be equal to 1. You also have a restriction that X cannot be equal to negative 4. Now, everybody listen to this for me. This is how I want you to write it. In the past, I've had Weber State unhappy with us saying this. X cannot be equal to 1 comma negative 4. They want those written as separate statements. Would they still get upset about that? I don't know. So just know it's best to write those as 2 statements. Yes, sir?
You forgot the X cannot equal negative 4.
Oh, good job. Thank you. Thank you. Good. Okay. The first thing we're going to find is a vertical asymptote. Okay. So to find a vertical asymptote, this is what you have to memorize. You let the denominator equal 0. Another thing you need to know, everybody put your arm in a vertical manner. What is vertical? Okay, so I used to mix those up, horizontal and vertical. So if you're like me and you used to mix that up, all you have to remember is the horizon. So if you're looking at the horizon, that's where the sun comes up and goes down. So that is horizontal. So the other one is vertical. Okay. So if you have a vertical asymptote, you guys, I really need you to know you can never cross a vertical asymptote. Okay. Okay, here we go. Question number 2. To find a vertical asymptote, you let the bottom equal 0. So we would say x plus 2 equals 0, so that's x equals negative 2. Okay, now draw an xy axis. And then I want you to come over here to the left 2. This is an asymptote, which means it's a restriction, right? So you're going to come like this, and you're going to dash it, and that would be the beginning of what your graph is going to look like. Okay, listen what people say to me every time I teach this. Now I'm confused because up above you said it can't be, and now you're saying it can be. So which one is it? Can be or can't be? Well, it can't be, and the fact that it's a vertical asymptote restricts the fact that x cannot be equal to negative 2. Who says I understand that? Raise your hand. Okay, good. Okay, let's do the next one. Set the bottom equal to 0. So we're going to go x squared minus 9, and I said equal to 0. Yes, it is supposed to be equal to 0. X squared plus 9 minus 9 equals 0. Bring your 9 over. X squared equals 9. Square root, and you get x equals 3. It is plus or minus. Why is it plus or minus? Because you took the square root. Some people, there's a problem that begins with the square root, Like, I didn't do it, it was there when the problem started, and then people will stick a plus or minus in front of it. Don't do that. It's when you take the square root. So yes, it's plus or minus, okay? And that's it. And what I would do, guys, I wouldn't put plus or minus. I would say x equals 3, x equals negative 3 if they're asymptotes. And the reason is, we're going to talk about in a minute, but some might be even and some might be odd, and that's going to be confusing. If you don't know what I just said, don't worry. I'm going to talk about it in a second. Draw an XY axis. Go to the right 3 and to the left 3. Take your pencil and draw asymptotes on both 3 and negative 3. Okay? Here's another thing I want to comment on really fast. Look right here. The red graph, right here, that red line, took my XY axis and split it into 2 halves, 2 parts, one on the right and one on the left. There will be something from the graph on the right, and there will be one thing on the left. One over here, one over here. Who says I understand that? Raise your hand. Okay, look here. How many pieces am I going to have to my graph right there? 3. One on the right, one in the center, one on the left. 3 pieces to my graph, okay? All right, here we go with question C. Find the vertical asymptotes. So you take the bottom and you set it equal to 0. And then you factor it. So it goes to x and x. Signs are the same, they're both negative. 3 and 2 multiply to give me 6 and add to give me 5. So I have an asymptote at x equals 2. And I also have an asymptote at x equals 3. As far as this particular problem goes, you're done. I want to start thinking about the graph. You don't have to graph it until Monday, but I want to start thinking about it. Go out to the right 3 units, dash in at 2, dash in at 3. That's what your graph on Monday is going to start looking like. How many separate pieces will I have to my graph? 3. 3. I did this. 3. Okay. Question D. Find the vertical asymptotes. So you have x squared plus 4 equals 0. That gives you x squared equals negative 4. Then you square root and you get x equals plus or minus. What is the square root of negative 4? It is called a 2i, okay, 2i. The negative makes it an I, the square root of 4 is a 2. Do you really think we're going to try to graph an imaginary vertical intercept? No. So what would the vertical intercept be? There is none, okay? That is going to be extremely rare, just so you know, that we would not have a vertical asymptote. Okay, odd and even. Okay, so you have to decide if the asymptote is odd or even. Understanding this right here is huge to being able to graph it on Monday, okay? Everybody look at this first one. See the x plus 2 on the bottom? I want you to put parentheses around it, and I want you to raise it to the first. There is one x plus 2 on the bottom, and that is an odd behavior, okay? Everybody write down x equals negative 2. I know that that's my vertical asymptote. If I set x plus 2 equal to 0, I get x equals 2. Now take your pencil and dash in right here at a positive 2 and a negative 2. Okay, one of these two things is going to happen. Everybody look right here for just a second, okay? Do me a favor and don't write, I want you to just watch, okay? So my body is the asymptote. My hands are the graph. If I have an odd number of things on the bottom, I only have one x plus 2, look what's going to happen. The graph is going to approach the asymptote, and one is going to go up, and one is going to go down. So it could look like that, but it could also look like this. I don't know yet, but I do know that they're going in opposite directions. Who says I understand that? Raise your hand. Great. Look at the other scenario. Now I have an x plus 2 to the second power. 2 is even. I still have an asymptote, you guys, at x equals negative 2. If I said x plus 2 equal to 0, I get a negative 2. So dash that in. This time it's even. Okay, everybody look right here. Eyes up for me, okay? Here's the asymptote, here's the graph. Even exponent, even number of x plus 2's means it comes like this, and they're going to go the same. So they're both going to go up, or as it approaches it from each side, they're both going to go down. Who says I understand? Raise your hand. Okay, good. Now, let's go back to the last problems, and we're going to decide if those asymptotes are even or odd. Okay, look. Question A. How many x plus 2's do I have on the bottom? 1. 1 is odd. So that's going to be an odd asymptote. Right now I can't tell if the right goes up and the left down or vice versa, but I do know they're going to go different. Okay? Look at this one. How many times did I have a solution of 3 from the bottom? 1 time. This one's kind of awkward. Here's a better way to explain it. Look right here. See this x squared minus 9? I could factor that to x plus 3 times x minus 3 is another way to do it. And then how many x plus 3's do I have? 1. So the negative 3 is odd. How many x minus 3's do I have? 1. So the x equals 3 is odd. So those would both be odd. Okay, who says I get this? Let's see. Okay, great. Look at the next one. X minus 2 came from here. How many do I have? 1. 1 is odd. X equals 3 came from here. How many do I have? 1. 1 is odd. So they were all odd. The last example doesn't have any. Will they always all be odd? No, they will not. Okay, now we're going to talk about end behavior. Okay, you guys, I need to be better about calling it an end behavior, because as I looked through the review for the midterm, Weber State just kept calling it an end behavior, end behavior, end behavior. So I'm going to be better about just saying what's the end behavior, okay? Remember we learned last time it's the up arrow, you know, all that business like that. So an end behavior could be a horizontal asymptote, okay? It could also be, the second thing it could be is a slant asymptote. I think that you guys may have called it, what's the other name for slant asymptote? Did you call it slant last year?
Yeah.
Okay. There's another name, oblique. Oblique. It's the same thing. Doesn't matter. Okay. Here's how you do it. Okay. This right here, you have two options. You can memorize it. Right there, those three things. Or you can think about it. I prefer to think about it. Okay, I don't like to memorize things. I just kind of reason through it. The way that you find a horizontal asymptote is biggest over biggest. I'm going to ask you that every time we find one. I'm just going to keep drilling you. How do you find a horizontal asymptote? And your guys' response is going to be biggest over biggest. Okay, let's go ahead and do it. One more thing, guys. It is okay to cross a horizontal asymptote. It's okay to do that. Draw an XY axis right here. Okay. People get confused on this, okay? So listen to this. Go out to like a 2 and go down to like a 3. So let's say I had something that had a vertical asymptote at 2 and a horizontal asymptote at -3. Okay, listen, this is big. Draw an arrow right here to that and say you cannot cross that guy. I know I'm going to have two pieces to my graph, one on the right and one on the left. Look at the horizontal asymptote. You can cross through. You can cross through. Maybe you will, maybe you won't, but it's possible. So what I want you to do is I want you to erase the center part of your horizontal asymptote. So the only thing I ever have you draw, guys, is the far right and the far left. Everybody look right here. If you have a horizontal asymptote, that's your end behavior. So the middle business we don't care about. You guys, it's an end behavior. So as x gets small, your graph goes there, and as x gets big, your graph goes there. So if we did have a horizontal asymptote, and you wanted to draw the arrows, look what your arrows would look like the arrows we drew last time. The arrows would look like that. As x gets small, it goes that way. As x gets big, it goes that way. That's what it looks like. Who says I understand? Raise your hand. Let me see. Do a big raise. Okay, good. Okay, here we go with question A. Find the horizontal asymptote. Here's what you do. Biggest over biggest. What I mean when I say biggest over biggest is the term that has the biggest exponent divided by the term that has the biggest exponent. Well, they're both just ones, right? So I want everybody to write y equals. You could write f of x equals, just write y equals. That would be 5x over x. That's the easiest scenario because look right here. If the top is equal to the bottom, y equals, see this ratio of leading coefficients? Just cross that out. And I want you to say simplify. That's all you have to do. So if you have 5x over x, everybody in the room tell me, can I cancel those x's? I can cancel the x's. So those x's would go away, and my horizontal asymptote is y equals 5. Looks like that. Now, you don't have to graph today, but I want you to draw an xy axis. I want you to go down 5 units. Then you're going to take your pencil and you're going to dash to the right and you're going to dash to the left. I'm not dashing the center. Why am I, did I do something wrong? Oh, silly. Silly. Thank you. I'm going to dash the right and I'm going to dash the left and I'm going to leave the center open. Why am I leaving the center open? Because it's okay to cross it. This is what people say to me all the time. Can I fill it in even though you don't want me to fill it in? Yes, but I would rather you not because I want you to come up to that dashed line on vertical and know you can't cross it, and horizontal and know that's where my graph has to go. So I would rather you not is the answer to the question. Okay, here we go with question B. Biggest over biggest. So the biggest exponent on the top is a 2. The biggest exponent on the bottom is a 2. So I'm going to have y equals 2x squared over 4x squared. Everybody stop for a second. If those exponents are the same, like on part A and part B, that is the easiest possible thing that can happen. Because then you just reduce it. So the y squareds just, pardon me, the x squareds just go away and you get y equals 2. Is it 2? A lot of people say 2. It is not 2. What is it? The 2 is on the bottom. The 2 is on the bottom, right? Oh yeah, it's on the top now. I understand the confusion. But when you reduce it, it's on the bottom. Yeah. Okay. Let's graph it. Everybody draw an XY axis. Go up 1. And then halfway down from that 1, dash a horizontal line, center open, just do the right, just do the left. Okay? Yes, sir.
So what happens to the +1 and the -9? Do we just forget the...
Okay, so I'm glad you said that. Every time I teach it, that's usually a comment. Remember last time's lesson when we were looking at things like this, everybody just listen for a second. Y equals 2x to the 4th minus 7x to the 3rd minus 1, and you were supposed to determine end behavior. And we said this affects it, but it doesn't dominate it. This affects it, but it doesn't dominate it. That dominates it. Same thing. Those dominate. Okay, so it still is going to be affected by it, but not dominated by it. Okay, okay, here we go with question C. Find the horizontal asymptote. So it's biggest over biggest. Now this one's tricky. Okay, look, I have a 1 here and a 2 here on my exponents. So everybody write y equals 2x over x squared. Now I want you to reduce it. So that gives you y equals 2 over x. Okay. If you memorize it, if you memorize that little thing, you're thinking here. If you figure it out every time, you're thinking here. So do whatever works for you, but you really don't have to memorize that stuff, guys. Look right here. So over here, okay, that's so weird. Oh, it was gone for a second. So the bottom right here is bigger than the top, so I know it's going to be y equals 0, okay? So if you just memorize it, then you can just say, oh yeah, I know if the bottom's bigger than the top, meaning bottom exponent bigger than the top, then it's a 0. Look right here for 2 seconds, and I want you to watch me reason my way through, okay? End behavior is as x gets small, where does it go? As x gets big, where does it go? It's not the middle, it's the small and the big, okay? Watch what happens. Just sit back and watch, okay? I'm going to start x with a 1. Then it's going to get bigger. It's going to go to a 2, then it's going to go to a 3, then it's going to go to a 4, and then it's going to go to 1,000. So if I put in a 1, 2 over 1 is a 2. If I put in a 2, 2 over 2 is a 1. Put in a 3, 2 over 3. Put in a 4, 2 over 4, that's a half. Put in 1,000, that's 2 over 1,000, which is 1 over 500. What is my y approaching? It's approaching 0. So just know, if you have x's on the bottom, as the x's get bigger, it's going to approach 0. Okay? Okay, let's do the next one. Biggest over biggest. Again, it's going to be tough. So this is y equals x to the third over x to the second. So that, if you reduced, would give you y equals x. If you have more x's on the top than on the bottom, as x gets bigger, then y also gets bigger. So there's no limit as to how big it can get. It's going to go big forever, small forever. So this right here is no horizontal asymptote. Your end behavior in this scenario is not a horizontal asymptote. It would be a slant asymptote. We're not going to find it yet. I just want you to know that if the top exponent's bigger, you've got a slant, not a horizontal. Okay? Who says I'm with you? I gotcha. Yes, sir.
Is that something you have to write, or we just have to say that there's none?
I would just say none. Literally, I wouldn't write anything on there except none. Yeah. Good question. Okay. Oblique. Okay. Up above the word oblique, I want you to write the word slant. Slant asymptote, oblique asymptote is exactly the same thing. Okay. So what you do is you do long division. Okay. Here's what you do. You take the bottom, put it on the outside, you divide it into the top, and you throw out the remainder. Throw out the remainder. Okay, here we go, nice and slowly. Find all the asymptotes. So look what we're going to do. We're going to go vertical asymptote, and then I'm going to go end behavior. Remember, I told you I was going to be way better about calling it an end behavior. The end behavior is either a horizontal asymptote or an oblique asymptote. Okay? Vertical asymptote. Nobody peek. Make yourself remember. Where do the vertical asymptotes come from? Tell me. The bottom. That's why this stuff is hard. You have to remember, how do I find that one? How do I find that one? How do I find that one? Vertical asymptotes come from the bottom. Set the bottom equal to 0, you get x equals 1. Everybody in the room tell me, is that an even vertical asymptote or is it odd? Tell me. It's odd. Write down that word odd. Let's see if I have a horizontal asymptote. So I would go y equals 2x squared over x. When I reduce that, I get y equals 2x. If the top is bigger, tell me the horizontal asymptote without looking. What is it?
None.
It's none. So my end behavior is actually an oblique asymptote. Okay, here's how you do it. Take the bottom, x minus 1, put it on the outside, divide it into the top, 2x a second plus 3x plus 1. Here we go. What do I multiply by x to get 2x to the second? That is 2x. Distribute the 2x. So people get confused right here. Look, guys. All I'm doing is 2x times x minus 1. When I do that, I get 2x to the second minus 2x when I distribute that. Okay? What do I have to do now? Can you tell me? You have to subtract them, which means change the signs. So this becomes a negative, this becomes a positive, and those go away. 2x plus 3x is 5x. Can you tell me what to do now? Bring down the 1. Then you start all over. What do I multiply by x to get 5x? That would be a 5. Distribute, and you have 5x minus 5. What do I do now? Change your signs. Yep. Those cancel, and you get a 6. There's nothing else to bring down. So the 6 is my what? My remainder, and I throw it out. So it's gone. So that's my answer. So my oblique asymptote is y equals x plus 5. Okay? Draw in an xy axis. Yeah. I wrote it right, but I said it wrong. I do that sometimes. Okay, go up 5. Make a dot. From that dot, go up 2 and write 1. You can also go down 2 and left 1. So make a few of these. Okay, and then look what I'm going to do. I'm going to dash it, and then I'm getting rid of those dots. I'm getting rid of the dots because I don't want myself to think that the dot is something that's on the actual graph. The dots helped me to draw my asymptote. Okay? Yes, sir?
Can you do synthetic division too?
Not yet. Not yet. Soon.
So like on the test, it could be synthetic division?
I think maybe by the time we get there, we'll learn synthetic, but I don't know. I have to look at what's coming. Okay, so the answer to your question is not yet. Okay? Okay, that's it. Okay? So your answer is vertical asymptote is this, and your end behavior is an oblique asymptote, and there it is. Okay? Question 5. Find the oblique or the slant asymptote. We're actually going to do more than that. We're going to find the vertical asymptote. We're going to find the end behavior, which might be a horizontal asymptote or an oblique asymptote. Okay? Vertical asymptote, every person in the room, make yourself remember, how do you find it? Bottom. So I have x equals 3. How many x minus 3's do I have on the bottom? 1. So this is odd. You guys, to find the horizontal asymptote, you don't even have to write anything down if you don't want to. You can say, I can see I have a squared on the top and a first on the bottom. My top exponent is bigger, so my horizontal asymptote is, tell me, none. There is none if the top exponent is bigger. So now I'm going to take the x minus 3, I'm going to put it on the outside, and I divide it into x to the second. Now we have a problem. Can anybody tell me the problem? When you use long division, you can't have anything missing. Here's what I'm talking about. This exponent is a 1. So I have to have an x to the first, and I have to have a constant, and I do. Look at the inside. All I have is an x to the second. So what am I missing? An x and a constant. So I have to fill in plus 0x plus 0. Those are just placeholders. They're going to help my long division go smoothly. Okay? What do I multiply by x to get x to the second? That's an x. Distribute, and I get x to the second minus 3x. Change my signs. First terms cancel. Add those together. I get a 3x. What do I do now? Bring down the 0. Yep. Go again. What do I multiply by x to get 3x? That would be a 3. Distribute. I get 3x minus 9. Change your signs. First things cancel. My remainder's a 9. Throw it out. So my oblique asymptote is x plus 3.
And it's y
Yeah, you're not going to get all the credit if you put x plus 3. That's not a line, that's an expression. It has to be an equation, so it's y equals x plus 3, okay? Draw an xy axis. Come out on the x to a positive 3 and dash in that vertical asymptote. Now let's draw the oblique. So go up 3, and then I'm going to go right one, up one, right one, up one, right one, up one. Well, I know it's going to hit over here at a 3 as well. And so it's going to look something like that. Okay? And again, you don't have to get to the picture yet, but I want you to start thinking about it. How many separate parts of my graph would I have on that problem? How many? I have one vertical asymptote. So how many pieces? Tell me. 2. One on the right and one on the left. That's it. Okay? Okay, holes. The only time you ever have a hole is if something, what's the word? Reduces. Okay, so highlight that word reduce. If you do have a hole, you're going to write it in the form of x comma y. We're going to do holes. I need you to understand holes, but I want you to know I have never one time, not one time, have seen Weber give my students a hole. Never. So I think the chance is super low, but I still want you to be prepared. Okay, so just know it's probably not going to happen. Okay, find the hole. Besides finding the hole, we're going to find the domain, the reduce function, the vertical asymptote, and I also want you to add something else on there, and that would be the end behavior. Okay, here we go. Don't peek. Make yourself remember. Everybody in the room, the first thing we're going to do is domain. How do I find domain? What do I do? Bottom, not 0. Beautiful. So it's x to the second plus 3x plus 2 cannot be 0. And then I'm going to factor, so it goes to x and x. The 2 goes to a 2 and a 1. Signs are both positive. So my domain is x cannot be equal to negative 2, and x cannot be equal to negative 1. That's my domain. Now, when you first do these problems, you guys, the first thing I always want you to do is to factor. So everybody write f of x equals the top factors. What is the rule that tells me how to factor the top? Do you remember the name? It doesn't matter if you remember the name. What does the top factor to? You're scaring me. It's called the difference of squares, and it factors to x plus 1 times x minus 1. Okay? The bottom, we just factored, it factors to x plus 2 times x plus 1. Okay? Can I reduce that, what I've got right there? Yes or no? Yes, I can. So I have exactly an x plus 1 and an x, exactly an x plus 1. Everybody freeze right there. If something reduces, then I know I have a, tell me, a hole. If you said x plus 1 equal to 0, you get x equals negative 1. That's the x coordinate of my hole. What is the reduced equation? It is x minus 1 over x plus 2. Okay? I want you to put a box around that, and I want you to write a note to yourself. Okay? And I want you to write down, once I reduce, only use the, does anybody have any idea what I'm going to say? Yes. Only use the reduced equation. Not the what, everybody? Not the original. So that thing's gone forever. Now you go here. Vertical asymptote. Where does a vertical asymptote come from? Make yourself remember. The bottom. So I have a vertical asymptote at x equals negative 2. Is it even or is it odd? It's odd. Someone tell me how I find the y coordinate of the hole. What do I do? You plug it in. Plug it in where? To the reduced. So everybody go f of -1 equals -1 minus 1 over -1 plus 2. That's a -2 over a +1, which gives me a -2. So there's my whole. I did want us to find the end behavior. The end behavior could be a horizontal asymptote. It could also be an oblique asymptote. Everybody in the room, make yourself remember. How do I find a horizontal asymptote? What do I do? Biggest over biggest. Okay, so that would be y equals x squared over x squared. Do I have a horizontal asymptote, yes or no? Yes, I do. What is it? Can you tell me?
0.
It's not 0. If I had 4 over 4, what would that be? 1, not 0, right? So the horizontal asymptote is y equals 1. Therefore, the oblique asymptote would be, tell me what? None. Yep. Okay? Yes, sir.
And that one we use the original equation instead of the.
Oh, no, you're right. You're so smart. No, you correct me like, he's corrected me like 4 times today. And guess what? I love that. It doesn't, like I'm confident in my abilities. And I keep doing like little mistakes and he keeps fixing it. And I'm like, dude, that's brilliant. Some people might be like, you know, mad about that. I celebrate that. So I plugged it into the original and I should have plugged it into the reduced. So that would give me, and that was to find the end behavior. So that would be y equals x over x, which still gives you a 1. So anyway, yay. Okay, let's draw a quick picture just to kind of put this all together. Okay, xy axis. Come over to a -2. Dash in a vertical asymptote. Then you have a horizontal asymptote at y equals 1. So come up 1, and then I want you to dash in a horizontal asymptote like that. You also have a hole at -1, -2. So that would be like that. The hole will always touch the graph. Say you have a graph like this, guys, look. Actually, I'll just draw it over here. Don't put it on yours. You're never going to have a graph like this, look. It would never be like that because the hole is going to end up right on the line. It's not like you'll have this random hole sitting there on your graph, okay? Who says gotcha? Let me see. Okay, great. Okay, x-intercepts and y-intercepts, couple more and then we're done, okay? I mean, how many times have we done this? So many, right? Do you think it's going to be on your quiz and your final and all that? Yeah, it is. Okay, x-intercept and y-intercept. To find the x-intercept, let y be 0. To find the y-intercept, let x be 0. Now, there is a little bit of a twist on this. It's not the norm, so watch. Y-intercept, let x be 0. So everybody go, g of 0 is 2 over 0 minus 1. That's 2 over -1, which is a -2. So if x is 0, y is a -2. No twist on that, okay? I'm going to tell you something right now. And if you can understand what I'm saying, it's going to make finding the x-intercept twice as easy. Okay? Listen. To find the x-intercept, you let y be a 0. Okay? Everybody go 0 equals 2 over x minus 1. Now I could cross multiply. Okay? But how about this? If I have a fraction, everybody just listen for a second. If I have a fraction a over b, and I know the fraction is 0, that's what I just did. The only way that a fraction can be equal to 0 is if what? Tell me. The top is a 0. So I'm going to say this to you 100 times. You're going to get so annoyed, and I hope you are annoyed, because then you're going to remember. This is what I'm going to say. To find the x-intercept, I let y be a 0, which is the same as letting the blank be a 0. Fill in the blank. What's the blank? The top. So all you have to do is let the top be a 0. Well, that's weird. 2 equals 0. Is 2 equal to 0? No. So it ended up being something weird, so the x-intercept is actually none, because the top can never be a 0. Okay, let's do the next one. On this guy right here. To find the x-intercept, I'm going to let y be 0. To find the y-intercept, I'm going to let x be a 0. Let's let x be a 0. So everybody go, h of 0 equals 2 times 0 plus 1 over 0 to the second minus 5 times 0 plus 6. The things without the x are going to remain, so that would be 1/6. So if x is 0, y is 1/6. Listen to my words. To find the y-intercept, to find the x-intercept, I let y be 0, which is the same as letting the blank be a 0, fill in the blank. The top. So you go 2x plus 1 equals 0. Move your 1 over. 2x equals -1. Divide by 2. X equals -1/2. So my answer is -1/2, comma 0. By the way, does that x-intercept, -1/2, 0, bounce or cross? This is last time's lesson. Bounce or cross? The -1/2 came from here. How many 2x plus 1s do I have? 1. 1 is odd. Odd means cross. Go back to the last one. We didn't even have one. Okay, let's do this one. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. Okay, go right here. Let x be a 0. So r of 0 is equal to 0 to the second minus 4 over 0 minus 1. That's a -4 over a -1, which is a +4. So if x is 0, y is 4. To find the x-intercept, you let y be 0, which is the same as letting the blank be a 0. What's the blank? The top. X to the second minus 4 equals 0. You can factor, or you can pull over the 4. So everybody go, x squared equals 4, square root it, x equals plus or minus 2. The only reason I think solving that way on the x-intercepts is confusing is the even odd thing. I think you can work through it though. 2, 0, -2, 0. How many times did I have a solution of +2? Just one time. So that's cross. How many times a -2? Cross. Might be easier to think about it like this. If I factor to x plus 2 times x minus 2, I have one of those, I have one of those. They're both odd, they both cross. Okay? Okay. Question 8, and then we're done. I don't think you're ever going to see this. Just so you know. Okay? Find the domain. Domain is x. Start from the left. Pull to the right. The easiest way to say this is cannot be. Okay? So tell me, actually, yeah. The easiest way to say this on the x's is cannot be. So x cannot be what, everybody? A -1, and x cannot be equal to a +1. Good. You could do plus or minus, it's fine. The range is y. Now there's a chunk of space where the y's are not defined. So cannot be is not going to work. Cannot be equal to. I'm going to do interval. So start at the bottom, -∞. And it goes all the way up to a value of, tell me everybody, 1/2, right? Does it touch the 1/2? So I close it with a what? A parenthesis. Then how about between a 1/2 and just below a 2? Is it going to touch anywhere there? No. So then it picks back up at a 2. How do I close my 2? With a bracket, because it actually touches a 2 and it goes on, tell me, forever, right? X-intercepts, you have 2 of them. They are -2, 0. Stop for a second. Does the -2, 0 bounce or cross? Tell me that. It crosses. How about the 2, 0? Bounces or crosses? Crosses. Look at the graph. What's the y-intercept? It is 0, 2. Horizontal asymptote. You have one of them. You could never assume, but they're telling you. What is it? 1/2. Yeah, the horizontal asymptote is y equals 1/2. How many vertical asymptotes do I have? 2. Everybody look right here. Remember I kept asking you and asking you, if you have 2 vertical asymptotes, how many pieces do you have to your craft? Do you see that? So I've got a piece over here, a piece in the middle, and a piece on the left, okay? So you have 2 vertical asymptotes, and those asymptotes are x equals 1 and x equals -1. Here's a question. Look at the x equals 1. This is big, right here. Is that asymptote even or odd? Tell me that. Is it even or odd? Everybody watch. This is, I think the biggest problem of people not being able to graph is right here. Look, here's an asymptote. See all this stuff? See all this stuff I'm touching with my hand? Don't even look at it. It's invisible. You're looking here. So as it approaches it here, it goes down. As this asymptote, the graph approaches it, it goes up. So it goes up that way and down that way. Now tell me. Odd. Good. Look at the next one right here. Everybody's eyes should be up. Okay, look. Here's your asymptote. Ignore all this. See all this? Ignoring. All I care is about this and this as it approaches. This guy goes down. This guy goes up. Tell me.
Odd.
Odd. Get it? Who just got it? Let's see. Okay. Now, all that stuff, you have to come to class on Monday with it perfect in your brain. Perfect, perfect, perfect. Because then we're going to put the whole thing together and we're going to start graphing. Okay? And I'll tell you, last year, I remember it not going as wonderfully as I'd hoped. There were people that were confused. Okay? Who says I understand today's? Raise your hand. Okay. Let me ask you one more question. I'll answer your question, but did I make another mistake?
No,
Okay.
I was just thinking that, like, how is it bracket 2 common infinity when we have 2 vertical asymptotes? Because isn't it not supposed to have a value there?
So you're thinking X's, but range is Y's. Are you okay?
Yeah.
So it's here that I'm moving, and it hits a 2 and above, and it touches it, so it's bracket, not this way. Okay? Yes, sir? You know, you really don't. I don't really know how picky they are with the use. The only time I ever tell you to use is when. Number line. Remember number line. Hey, who says this? So this little paper that I have, it's pretty cool. Like it says, first do this, then do this, then do this. Here's how you do it. Blah, 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 blah. Get the graph. I'm kind of afraid to give them to you. I'm afraid that you're going to use them too much and you won't make yourself think. Who says, I don't even want a paper because I'm going to depend on it too much? Who says, please give me a paper?
I want to see the paper.
Okay.
Like, so I can look at it, so I can get it in my head.
Okay, and that's good, but then what
But
I
then
want you to
get rid of
do, flip it over, okay, as soon as you can, okay? Good.